Now we are approaching our test on systems. We've spent quite a bit of time on this, so it's good to see this review. Let's get cracking on it. Make sure you guys are doing the best you can. And remember, first thing you want to do, don't just watch this video first. Try to treat this as if it were the test. Show your work, do every single problem the best you can, and then watch this and you can kind of go through and see and fix mistakes or see what you did right. So let's get going on this. So these first ones, you're just basically solving the system of equations and you're given some possibilities. Okay, now there's a few different ways you can do this. Okay, one way is to simply solve the systems, which this one you can graph it or, do substitution or elimination, right? We have those three that we can deal with. Graphing, elimination, or substitution. Okay. So, and I will go over each one of those. So, instead I'm going to show you a different way. This one I would probably graph, actually, if I had a graph paper. If not, I'd use elimination. Or substitution would be an easy one too. But what you can do is just start plugging in these numbers, okay, for x and y. Because if they are solutions, they'll work. The thing is, you've just got to check for both. So, this may be faster, this may be slower. But I just wanted to show you on these ones what you can do. So 2 times 4 is 8, 8 minus 3 is 5. So A worked on the first one. We could try it on the second one. 5 for y, negative 4 for, because of that negative right there, plus 3, that equals negative 1, does not equal 5. Okay, so we know A is out. Then we can try B. B, 2 for x. So 2 times 2 minus 3 equals 1. 2 times 2 is 4, minus 3 is 1. So yeah, B works on the first one. Okay. What about on the second one? So 1 equals negative 2 plus 3. That would work. So that's our answer. Okay, that's the one that works on both. If you wanted to double check, you could do C. Go 5 for y, negative 2. You get negative 4 minus 3, negative 7. Doesn't work on the first one, so we know it doesn't work. Probably works on the second one, but we wanted the one that worked on both of them. So you could do that to check those ones. Okay. On number 2, you could do the same thing. I would probably do substitution on number 2, though, because I've already got y is by itself. But you don't have to. Okay. On this test, you can choose whichever way you want to. You could graph these. You could do substitution, elimination, or you could just use the points on one of these type of problems. Because they give you the solutions, the possibilities, okay? So, but I'd do substitution. So I'd substitute that in for y. So I'd have x plus 2x plus 4. Because I replace the y with this, equals negative 5. Okay, x and 2x give us 3x plus 4 equals negative 5 minus 4. 3x equals negative 9. Divide by 3, and x equals negative 3. So I know it's either A or B. Then we plug it in, that negative 3 for x, in one of our other equations. We'll use that one. So negative 3 plus y equals negative 5. Add 3, and I get y equals negative 2. So my answer is B. Okay, see, that's honestly probably quicker than doing it the first method. So, and that's probably, substitution is probably the slowest out of all of them. Okay? Alright, now what I'm going to do on these next problems is I'm going to do every type of way that you can solve this. So I'm going to do graphing, elimination, and substitution. You pick the one you like to do best, and that's the one you need to practice with. Okay? I'm just showing you all the possibilities. So, 3, graphing. We'll start with graphing. Y equals 2. No x, that tells me it's a horizontal line at 2. The next one, negative 4, go down to negative 4. Slope is 3 over 2 up, 1, 2, 3 to the right 2. You can see exactly where they intersect. And my answer is 4, 2. Okay. Now if I wanted to do substitution, I'd say, well, I already know what y equals. So I'm just going to substitute in 2 for the y and then solve. So add 2. So we get 4 equals 3 halves x times both sides by 2. That'll eliminate the fraction. Divide by 3. And what did I do wrong? Oh, duh. That should have been a 4. Like, something's not right here. So that would have been a 6. So that would have been a 12. So that makes sense. X equals 4, and we already knew y equals 2. Okay, so that was substitution. Now with elimination, this one's kind of tough to do on elimination. But you still can do it. So far it looks like graphing was the easiest on these ones because they were both in slope-intercept form. But if I want to do elimination, I'd have to go y equals 0x plus 2. I'd have to put an x term in here, or else it wouldn't work. Then I could subtract, because 1y minus 1y would be 0y. We'd get negative 3/2 x minus 4. I could add 4 to both sides, and we'd get 4 equals negative 3/2 x, and this looks pretty familiar, doesn't it? So we'd get 8. What did I do wrong here? I'm not used to doing them when we didn't have the x term. Oh, duh. 2 minus a negative 4 would be 6. Oh my goodness. So, here's the first lesson of today. You guys got to pay attention to what you're doing, because if not, you make stupid mistakes. Just like I'm doing. So negative 12 equals negative 3x divided by negative 3. We get 4 equals x, which then we already know that y equals 2, so we're good. Okay, so that's using all methods on that one. Which would I prefer to choose on this one? Graphing. That's the one I think is the easiest there, though substitution wasn't too bad. Okay, the next one. So let's start off with graphing. Once again, they're in slope-intercept form, so I think those are the easiest to graph. So negative 2, and you've got a graph here. Negative 4 over 1, down 4, to the right 1, or up 4, to the left 1. There's our first line. Then do our second, start at positive 4. Slope of 2 over 1, so up 2 to the right 1, or down 2 to the left 1. I can see exactly where they intersect. My answer, negative 1, 2. Okay, now if we were to use elimination, we'll switch and do that one next. I would say, okay, positive 1, subtract, so 0y equals negative 4 minus 2, negative 6x. Negative 2 minus 4. And if you have to, write them out. It's negative 6. Add 6 to both sides. That's 0, so we just get 6 equals negative 6x. Divide by negative 6. We get negative 1 equals x. Then pick one of our equations. Put in negative 1. So negative 2 plus 4, and solve for y. So 2 equals y, which is exactly what we got there. Okay. So, there's graphing, there's elimination. Now let me show you substitution. So in this, negative 4x minus 2 is equal to y, so I'm going to replace the second y with negative 4x minus 2, and that'll equal 2x plus 4. Now I combine x's, add 4, get negative 2 equals 6x, plus 4, subtract 4, negative 6 equals 6x. Divide by 6, negative 1 equals x. Then take an equation and plug it back in, which we already did that part. That part's the same, isn't it? So we end up with this, so 2 for y, which is what our answer was. And remember, we put it as point negative 1, 2. Okay, so you can judge just which one you think is the quickest and easiest to go with. Alright, number 5. Start out with graphing. Now what I should notice right off the bat, those are parallel. They have the same exact slope, but they have different y-intercepts. So if I start at different y-intercepts, what do we get? We get parallel lines, which are not. There's one of my lines, my top one. There's my bottom one, parallel. So we call that no solution. Okay. Checking it out with elimination. we would subtract 1 minus 1 is 0y, 4/3 minus 4/3, 0x, negative 2 minus 4 is a positive 2, because negative 2 minus negative 4 would be plus. Does 0 equal 2? No, it does not. No solution. If we're using substitution, they're both equal to y, so I set them equal to each other. And what's going to happen? Well, we'd subtract 4/3 x. That would eliminate. 0 minus 2 equals 0 minus 4. Is negative 2 equal to negative 4? Nope. Once again, no solution. So, once again, I think you could probably have figured that out just by looking at those two equations and seeing that they have the same slope. Okay, number 6. This is one where graphing might not be the quickest way to go. Okay, so let's try elimination first. So I need to match them up, so I'm going to times them by 2 at the top. So I get negative 4x plus 2y equals 10. Right off the bat, I know exactly what's going on. Those are the same exact lines, aren't they? So I know that's infinite solutions. Okay? So, because I would have ended up with 0x plus 0y equals 0. So 0 equals 0, that would have been true. Now, if I would have done substitution, I would have added the 2x to both sides, right? So we would have had y equals 2x plus 5, which I would have substituted in for y, which most of you don't like this one, so just don't pay attention. That would have given me 4x, so negative 4x plus 4x plus 10 equals 10. Those would have canceled. 10 does equal 10. Tells us infinite solutions. Okay, had I tried to graph them, well, let's see, I already turned that into slope-intercept form, so I could have graphed it, and it would have looked like this. I'm trying to go pretty quick on some of these. If I would have manipulated this, I would have added 4x and got 2y equals 4x plus 10. Divide by 2, and you would have found off right here that you have the same exact equation. So that's how you approach all of those problems. Okay, now number 7. Okay, if I'm going to graph it, the first one's easy, it's in slope-intercept. So down to negative 8, which would be 5, 6, 7, 8. Up 4 to the right 1. Okay, there's my first equation. Now my second, I would have had to change into slope-intercept form. That would have got me 4y equals x plus 13, which I also would have had to do had I been doing elimination, right? I would have wanted to get my two equations to match. So then I would have divided by 4 here and got y equals 1/4 x plus 13/4, which that's not very pretty, is it? 13/4 being, let's check it in the calculator, 3.25. So it went up to 3.25 and then up 1 to the right 4. So I probably would have intersected right up there, but I'm not sure what that would be, right? So graphing, probably not the best one here because this one's a little sketchy. However, had we done elimination, I could have said, okay, let's get one of these to match up. Let's times the top by 4 to get the y's the same. So I would have ended up with 4y equals 16x minus 32. Subtract, that would have been 0y equals 1 minus 16 would be negative 15x. 13 minus negative 32. That would be like plus, right? So that would be 45. So plus 45. Add 15x to both sides, because that's 0. So 15x equals 45. Divide by 15. And we get x equals 3. So it would have intercepted up there, But see, with that graphing, it just made it tough trying to figure that out, didn't it? Okay. So, then we pick one of our equations. So y equals, substitute in 3 for x. 4 times 3 is 12, minus 8 is 4, so y equals 4. So it would have intersected right there, but it was hard for us to see with the way we graphed it. So, 3, 4. Here's one instance when graphing would not be the best route to go. I really liked elimination, but I could also do substitution. Substitution, that's equal to y, so I substitute everything into that y variable. So it would be 4x minus 8 instead of y. Then 4 times 4 is 16x, 4 times negative 8. Notice that it's kind of looking a lot like the other problem. Okay, so, that should have been 32, not 12. Adding those. So add 32, and we would have got 45 equals negative 1 plus 16 would give us 15x. Seeing we end up with the same exact type of problem. Plug it back in, and you get the y part. Okay, I'm not going to show that because we already did that. Alright, number 8. This one's all set up for elimination, so that's probably the easiest one, because you'd add negative 2 plus negative 9, negative 11x, 1 plus negative 1, 0y, 0 plus 22 is 22, negative 11x equals 22, divide by negative 11, x equals negative 2. Now that we know x is negative 2, we take the y and plug in the number for x to figure out the y. So positive 4 plus y equals 0, subtract 4, so y equals negative 4. So my answer, negative 2, negative 4. Had I wanted to do substitution, we would have had to solve for one of these y's. So I would have added the 2x and got y equals 2x plus 0, which is the same step I would have done if I was trying to solve this for graphing, that slope-intercept form. But then I can get rid of that plus 0. So now I know that for my y, I can replace y with a 2x. So negative 9x minus 2x equals 22. Negative 11x equals 22. And x equals negative 2. Then once we knew what that was, I do the same step I did here, come up with the same answer. Okay? Now if I graphed this, that one we changed and it became y equals 2x, right? This one I would add 9x. Take negative y equals 9x plus 22. Divide by negative 1. I get y equals negative 9x minus 22. Okay? Which is a lot harder to graph, isn't it? Y equals 2x. Start at 0, 0. Up 2 to the right 1. Or down 2 to the left 1. Okay, if I'm doing this other one, I'd have to go clear down to negative 22, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there'd be my y-intercept. Let's do it in blue. Then my slope is negative 9 over 1, so I'm going down and to the right or up and to the left. So I need to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. To the left 1. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. To the left 1. So we can still see where they intersect, can't we? It was at that negative 2, negative 4. But, as you can see, graphing may not have been the best one there. Elimination seemed to be perfect for that one. Alright, so we're done with those types. Now let's take a look at a story problem. So, the school that Gabriella goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 2 adult tickets and 7 child tickets for a total of $43. The school took in $39 on the second day by selling 1 adult ticket and 7 child tickets. What is the price each of 1 adult ticket and 1 child? So we're looking for price here, right? So we need to understand that. So we've got an adult ticket price and a child ticket price, which is what we are looking for. So, we could call this our adult or the other one. It doesn't really matter with the graph. But we need to make an equation. Now these ones are set up to work great with standard form. Because I say, well, if I sold 2 adult tickets, I multiply it by the price, right? A. I'm going to add to that however many child tickets I sold multiplied by the price. And that's going to equal 43. Well, I do it for the other one. So they took in 39 by selling 1 adult ticket, so 1A, and 7 child tickets, 7C. Now, if I look at this, I can set this up easily to work with elimination, right? Because I've got 7 and 7. My 2 coefficients are exactly the same. So I'd subtract 2 minus 1 is 1A, 7 minus 7, 0C, 43 minus 39. This is kind of like those dog and cat bag things, okay? So 43 minus 39 is what, 4? For some reason that was harder than it should have been. So A equals 4. What does that tell us? The price of an adult ticket is $4. So if I know the price of an adult ticket, right, I can use one of these equations and say 1 times 4, right, plus 7C equals 39. So that's 4 plus 7C equals 39. Subtract 4. 7C equals 35. Divide by 7. And C equals 5. So what does that tell us? Child ticket is $5. So this must be something like the Wiggles. Okay, that's one way we could have solved it. One way we could have solved it. The other way, with substitution, because I'll show you all 3, that's the elimination is the one I would have chose, though. Okay? So I could have said, well, this is 1A. I could have subtracted 7C from both sides, right? I got 1A equals 39 minus 7C. Then I would have went 2 times, substituted in, and I would have solved like this. So 39 and 39 is 78 minus 14C plus 7C equals 43. Added, oh, not added, 14C. Combined like terms to get negative 7C. Subtracted 78. And we would have got 43 minus 78 to be negative 35. So negative 7C equals negative 35. Divided, and C would have equaled positive 5. And once we knew what C was, right, we could have just plugged it in here and got 35 and subtracted 35 and got A equals 4. Okay, so that's another way we could have done it. The last way would have been to graph it. Let me clear this. So to graph it, we would have went to A plus 7C equals 43. 1A plus 7C equals 39. We just said, well, let's call this children and adult. So A is like the Y, so we'd subtract 7C from both sides. So I'd get A equals negative 7C plus 39. This one I would have subtracted and got 2A equals negative 7C plus 43 divided by 2. I would have got A equals negative 7 half C. And let's see, 43 divided by 2, that gave us 21.5. Then I could have graphed these, and where they would have intersected would have worked. Now this one's going to be a little tough with that 21.5, so that's why I'd suggest not graphing on this one. I would have to call this 40, which means 39 would have been right there. We would have went down 7 to the right, down 7 to the right. You know, we would have ended up at, see if I'm counting by 2s. 2, 4, 2, 4. Child ended up being 5. Children's ended up being 2, so it would have been like right there. So it would have been a tough one to graph, so don't do it. In these story problems, usually elimination or substitution works much better. Okay, number 9. So what types of answers do we have, and how do we see it graphically or algebraically? Well, we've got one answer, right? How do we see it graphically? Well, 2 lines intersect, right? So it's a intersection point. At the point x comma y. Algebraically, we get x equals a number and y equals a number. Okay? The other type of answer is no solution. Okay, what does that look like graphically? Well, parallel lines, right? So we could write parallel lines. How do we see it algebraically? Well, we end up with like 0 equals -5. Or, something like that. Two numbers not equal and no variables. Two numbers that are not equal. So in the final is infinite solutions. How do we see that? Well, graphically, it's the same line just overlapping, right? So same line overlapping. How do we see it algebraically? We end up with something like 0 equals 0 or -5 equals -5. Two numbers that are equal and no variables. Okay? Alright, so now we may not have enough time to take a look at these problems on this one, but I'm going to give it a shot to see if I can at least get done with one of these. So, Fernando and Melina are both members of Vasa Fitness. They each choose different plans when they signed up. Fernando was bragging to Melina that he would soon be much stronger because his plan included a personal trainer. Fernando pays $10 a month for his membership and then $5 for every session with a trainer. Okay. Melina and her friends all signed up together, so they work with a trainer in a group setting. So her membership cost is $5 a month, with each training session costing $6. Who made the better deal for their gym membership? Which membership would you choose? Typo. Make sure to provide a mathematical model to show the reasoning for your answer. The way I would start this is with a table. Okay, let's call this Fernando, purple. So really what we're judging here is the cost in a month, depending on a session with a trainer, right? So a session with a trainer. So if they just go to the gym without the trainer, Fernando pays $10 a month. If he goes once, he adds $5 to that, right? Because it's 5 for every session, 2. So he's counting by 5s. Okay, so we could keep going. 35, 40, 45, 50. We'll stop right there for now. Okay, now that's Fernando. Now Melina, same idea. Okay, if she doesn't go to a training session, it's only 5. But if she does, we're adding 6, right? So it'd be 11. So 2 sessions, 17, at 3 sessions, 23, at 4 sessions, 29, at 5 sessions, 35, at 6 sessions, 41, 7, 47, 8, 53. So what we should notice right here is one thing. First of all, if it's less than 5, Melina's got a better deal, right? She's spending less. At 5, it doesn't matter, at 5 sessions. But greater than 5, then Fernando is cheaper. So which membership is cheaper depends on how many sessions, right? So you'd write this something like, Fernando is cheaper when the sessions is greater than 5. Okay? Melina is cheaper if the sessions are less than 5. If they go to 5, it's the same. Okay, and that table is a great way to tell. Now, could I have done something else? Yeah, I could have come up with some equations. Okay, Fernando would have been y equals, or I guess c equals 5x plus 10. Melina would have been y equals 6x plus 5. And then I could have found out where they intersect using a system. That wouldn't have been a good way to tell me higher or lower. Graphing would have been another great thing to do. And then this last one, which would you choose? Well, looking at how much the cost is, I probably wouldn't go very many sessions with a trainer, so I'd probably go with Melina's session. Okay. Now, I think I've missed another problem here, so I think I've got 2 more problems, right? Is there one with how did I skip that? One with the cows and chickens. Okay, so we've still got the bonus one. I've still got the cows and chickens one, so we'll do another video for that.